Okay, so this exercise is very important. Why? Because what we have just done, okay, just a general overview for you, is we have done from element to Mohr circle. Mohr circle, we bring it back to the what? To the element. Okay. So at that orientation is where your shearing stress is equal to 0. You only have what? Normal stresses. Are we clear? Okay. I'm going to do another example. Okay. I think I'm going to do a different stress magnitude, so it can help you to identify the shear, because a lot of times students get confused. It's because of the shear. Okay. So let's do a different problem now. So I'm also still going to construct a Mohr circle, okay, but the problem now I make it more, not impossible, okay, but more difficult. So example number 2, I'm going to change things a bit. Okay, so this is my X, Y, okay, and then we're going to have an element. Okay, this is an element. So the element has a normal stress of 50 degrees, right? What do you mean 50 in normal selfie, Eugene? Come on, 50 megapascal. Okay. And then it has now a negative shear and a negative shear of 30 megapascal. Okay. It has a negative shear of 30 megapascal. So what we want to find now is we want to find the stresses so we want to find the stress so we want to find the stress at when the plane, okay, find the stress when the plane is rotated 35 degrees clockwise for horizontal. So we want to find the stresses on the plane. Okay, determine. Okay, we're going to determine the stress state along the plane that is rotated 35 degrees clockwise from the horizontal. Okay, that's what we want to do now. Okay. Okay. So now what we're going to do is we know that this we're going to label this as X, Y, And because the plane is rotated from Y, I'm going to call this plane Y35. Okay, I'm going to call that plane Y35. Okay, so we know our stress X is equal to 50 megapascal. We know that our stress Y is equal to 0. And we know that our shear XY is equal to shear YX is equal to minus 30 megapascal. Again, don't worry about the minus sign on shear, because on Mohr circle, the shear is dependent on the rotation of the element more than anything else. Okay, so now we're going to draw Mohr circle. Now you have to learn how to draw Mohr circle, because in the exam, I know you can use a bunch of formulas. In the exam, I will specify that you have to use Mohr circle. If you don't use Mohr circle, marks will be deducted. Okay, so when you have to, and Mohr circle is easier for a lot of problems. Okay, so this is our normal stress. This will be minus 80, 60, 40, 20, 0, 20, 40, 60, 80. Okay, and then we have our shear. Okay, so this is our shear. 20, 40, 60, 80, minus 20, minus 40, minus 60, minus 80. Element rotate clockwise at the top, anti-clockwise at the bottom. Okay, right. So we have zero stress. So this is our stress Y line, and our stress X line is positive 50. Okay, so we are going to have positive 50. Okay, so this is our stress X. And then we have a shear of 30. Again, I understand it's negative 30, but you just have to draw positive, because the shear is dependent on the rotation, not on the magnitude. Okay, so it's 30 down here. And then there's another 30 down here. Right? So let's focus on X. Okay. So X will lie on this orange line over here. And then when you put a pin on the center, the 30 over here will want to induce a rotation in a what? In a clockwise direction. Okay. So this is now your point X. Okay. And then if we were to do our point Y, okay, so this is our point Y now, right? You look at this arrow over here, it's going to do a counterclockwise rotation of element. So counterclockwise of element. So this is your point Y. Okay. And I hope it's clearer for you now. Okay. So from here, you draw a line. Right. Then exactly now you draw a line coming down, which is your stress average line. And this is going to intersect somewhere around here. Okay. So this over here over here is your 0.0. Okay, so we can do some calculation on this, right? So we have found the center of the circle, which is your stress average, which is equal to 50 plus by 0 divided by 2. This is 25 megapascal, right? We know that now. Then we also can find the radius of the circle, which is your tau max. So if I were to bring the, right, so what we have over here, we know that this is this distance over here right is 30, and we also know that this distance over here is 25, right? So your tau max will be equal to square root of 25 squared plus by 30 squared. So it's equal to 25 squared, 39.05, 051 megapascal. Okay, so 25. So you can see the procedure is pretty standardized, right? So from here, you can calculate your stress 1 and 2, which is your principal stress. So it's 25 plus or minus 39.051. So this is equal to 25 plus 39.051 is 64.051 and minus 14.051 megapascals. Okay. So now you can construct. I mean, for me, I need that value to construct Mohr circle. For you, just take a protract compass and you can start drawing. Okay. So we know the maximum shear is 39. Okay, again, I'm eyeballing this. And the minimum stress is minus 14. And the other side is 64. Okay. So this is your XY plane Mohr circle. Okay. Right. So this part is done. Then you can also find your principal plane. Okay. So tangent to theta p is equal to 30 divided by 25. Right. So 2 theta p. Yes. So 2 theta p. Pardon me. Tangent 2 theta p is equal to 30 divided by 25, 2 theta p. So 30 divided by 25, it was tangent 50.2 degrees. Okay, that's our principal plane orientation. Now, the tricky part comes over here. Okay. From point Y, right, it's going to rotate 35 degrees clockwise from point Y. I repeat again, from point Y, it's going to rotate 35 degrees to Y35, okay? So over here, you take your angle from point Y, not the horizontal axis, okay? You take it from point Y. And because on the element is 35 degrees, on Mohr circle is what? 70 degrees. So I'm going to look for 70 degrees. Okay, I'm looking for 70 degrees now with my protractor. And it's not easy to use protractor on digital screen. And then this is my 70. Okay, so this is my 70. Okay, so this point over here, this is my Y35 point. And it's rotated from Y to here, and the angle over here is 70 degrees. Why? Because on the element is what? 35. Okay, clockwise direction. Clockwise direction from point Y is 35. So now, we now have to find what? We now have to find, right? Now we have to find, if you look at this point over here, it's run by two coordinates, right? Stress Y35 and shear Y35. On the opposite side, okay, we can label this as your X35. Okay, because one point is Y, the other point is X. So this is your stress X35. And your shear X35. Okay. Right. So the first thing we're going to do now, right? We have to do some very basic calculation. We want to calculate this angle over here. We will call angle alpha, right? And we do know, right? What we do know that is this angle over here. I will use a different color. This angle over here, which we have found, right? This angle itself is what? 50.2 degrees. Okay. So now we want to find alpha. Okay, we want to find alpha. So alpha is equal to 70 minus by 50.2. So 70 is equal to 19.8 degrees. Okay. Okay, what I propose is we take a 5 minutes break. Okay, we come back at 8:17. Okay.